Here are the three most important conservation laws in physics, which hold for all isolated systems. The first is the conservation of charge, which tells us that the total charge of an isolated system remains constant. Charge can neither be created nor destroyed, but can be transferred from one part of a system to the other, to another. The second important conservation law is the conservation of mass, which kind of follows from the conservation of charge. Every mass is made up of particles, and the particles in turn have charges. So the conservation of mass kind of follows from the conservation of charge. Mass cannot be created nor destroyed, but can also flow from one part of a system into another. And the last important conservation law is the conservation of energy, which also kind of follows from the conservation of mass. Einstein's equation, E equals mc squared, tells us that mass can be converted into energy, and the constant that links them is the speed of light, which is a fundamental constant. So conservation of mass implies conservation of energy according to this equation. And this tells us that indeed the total energy of an isolated system remains constant and expresses the fact that energy can neither be created nor destroyed, but can be converted from one form to another one.